Alright, welcome back. It's nice to see everyone again. I hope you had a nice spring break, and last week really didn't have to do a whole lot, just watch some short videos. But from the comments, it seems like you guys understand what's going on, so we will pick up where we left off. So today's the 27th. And let's see what we have going on here today. Alright. So we're going to be doing section 6.2 today. Section 6.2 we'll spend a few days on. It's called Amplitude, Period, and Phase Shift. And just as a reminder about what we did before we left for these 2 weeks, we talked about different shapes of graphs. We said that sine and cosine are similar. We said cosecant and secant are similar. And tangent and cotangent are similar. We could group them by shape. Sine and cosine look like waves. The way we figure out what the graph looks like is we use a calculator. We plug in different values every 90 degrees, or even shorter than that, until we get what the shape of the graph looks like. For, let's see here. For cosecant and secant, they are alternating parabolas, so they look like this. Tangent looks like a regular cubic, and cotangent looks like a cubic going the opposite direction. The way we graph cosecant or secant is we figure out what would sine be, and then we do 1 over that. So that's a review of their shape. As far as their period, sine and cosine have a period of 360, or 2 pi radians. Cosecant and secant have a period of 360 degrees, or 2 pi radians. Tangent and cotangent have a period of 180 degrees, or pi radians. Period means how often they repeat. And then the last one is amplitude. Amplitude is just the height of a wave from the middle. Sine and cosine usually have an amplitude of 1, and everything else we're going to say none for these graphs. So that's a little bit of a review about where we're coming from. All right, so now let's get into this new lesson. For the new lesson, we're going to focus on just a general equation. Just like you guys are used to seeing something like this. F of x is equal to, let's say, just x squared, right? We could change it if we write an equation. F of x is equal to 2 times x minus 3 squared plus 1. This is going to be similar to the amplitude. It's going to make the graph stretch, get narrower or wider. This number is going to relate to our phase shift, which is going to move the graph left and right. All right, so that's just kind of like a little review. So let's actually do the trigonometry here. If we have a general equation like this, f of x is equal to a times the sine of k theta minus ps. And I'm going to explain everything, so it'll all make sense in a minute. What this tells us is I'm going to ask you to find the amplitude, period, and phase shift. The amplitude is always going to be the absolute value of A for sine and cosine only. The phase shift is going to be the number inside the parentheses once theta or x is by itself. And I'll explain this with some examples. And also with the phase shift, you might have to factor out k first. And then the last one is the period. Now the period is going to be the normal period divided by whatever k is. Normal being, like for sine, the normal period is 360. When we're saying normal, what that means is this. Those are normal periods. All right, so let's take a look at a few examples. I'll ask you to find the amplitude, period, and phase shift. Say we had y is equal to -2 times the sine of 3 theta minus 45 degrees. To get your amplitude, it's going to be the absolute value of -2. Absolute value always gives you a positive number. To get the period, we always want to make sure that theta is by itself, and this is the k value. So the period is always the normal period divided by k. Well, the normal period of sine is 360 degrees. Divided by 3 is 120 degrees. That's the period for this, which means this graph's going to be a little shorter. Instead of repeating every 360, it's going to repeat every 120. And then the last one is the phase shift. And theta is by itself, so it looks like this graph is going to be 45 degrees to the right. That's how you do a problem like that. What about something like this? If it was y is equal to 3 times the tangent of 2 theta plus 90 degrees. The first thing we should do is always make sure theta is by itself. It's not by itself, so the way we get it by itself is we could factor out the 2 from the inside. And just like with polynomials, we could factor out a 2, divide everything inside by 2, and now we're all ready to go. What would the amplitude be? Trick question. The actual amplitude is none. The only graphs with amplitude are sine and cosine. This is a tangent graph, so there's no amplitude for tangent. It's a trick question. You can guarantee I'm going to be using that one a lot to try to see if you're paying attention. The only graphs with amplitude are sine and cosine. If it's not sine or cosine, there's no amplitude. The period, now that theta is by itself, it's going to be the normal period of tangent divided by 2, which is 90 degrees. It's a little shorter, kind of like me, but that's how you would figure it out. And then the phase shift, theta is by itself, so we're going 45 degrees to the left. Remember, anytime it's on the inside and it's positive, we go left. When you're telling me phase shift, I have to see the number, and I want to know what direction it goes. Maybe we'll do a couple more. What about a problem like y is equal to the cosecant of theta over 2 plus 90 degrees? Now remember, there's no amplitude because it's not sine or cosine, so you put none. Anything else would be wrong. It has to be none. Second thing is your period. Well, theta is not by itself. Dividing by 2 is the same thing. So this is the same thing as saying the cosecant of 1/2 theta plus 90. Dividing by 2 is the same thing as multiplying by 1/2. So we have to actually factor out the 1/2. And what's 90 divided by 1/2? It's not 90 divided by 2, it's 90 divided by 1/2, so it's 180. The period is the normal period of cosecant divided by the number in front. 360 divided by 1/2 is 720. Don't confuse it with dividing by 2, we're dividing by 1/2. And then the phase shift for this would be 180 degrees to the left. All right. Let's try something else. What if I asked you to write an equation for sine with an amplitude equal to 3, phase shift of 30 degrees to the left, and period of 180 degrees? Well, we're going to have to fill in the blank here. So it's going to be y is equal to something times sine, something in front, and then theta, and then something for the phase shift. Well, the amplitude is 3, so we could either put 3 there or we could put -3. It doesn't matter. That would be that. The phase shift is 30 degrees to the left. That's what we write. Now, the only trick is you have to figure out what k is, right? Well, the number that's there, we divide by the normal period to get the actual period. So let's just put k here for now. We don't know what it is. But I know the normal period is 360. 360 divided by whatever k is would give you the period, which I told you was 180. So if you multiply both sides by k and divide by 180, you get k is 2. So I'm going to put 2 here. All right. That's how you do those kind of problems, and I'll show you how to graph a couple, and I think that'll be it today. Let's graph 2. Let's graph y is equal to, let's say 2 times the sine of theta plus 90 degrees. Now you're going to want to have a calculator ready. We're going to use the storing function. First thing we always do is figure out what's the amplitude, period, and phase shift. Now the amplitude's 2, so when we go to graph this, the highest it's going to go is 2, the lowest it's going to go is -2. There's no number in front of theta, so the period is just going to be the normal period divided by k, which is just 1. This graph's going to repeat every 360 degrees. So I'm going to go, whenever I ask you to graph anything, I always ask you to go from -360 to +360. And then the phase shift would be 90 degrees to the left. So I'm going to use my calculator to graph this. Let's figure this out. I'm just going to pick a few numbers until I start to get the hang of things. Like let's start at -360. I'm going to store that into my calculator, and I'm going to type in 2 times the sine of a plus 90, making sure my calculator's in degree mode. So I'm going to store -360. And I'm going to type in 2 times the sine of mem variable a plus 90. Hit enter. And my calculator is telling me 2. Now the period's 360, which means 360 degrees later, it's going to be 2. 360 degrees after that, it's going to be 2. What about at -270? I'm going to store -270. And my calculator is telling me it's 0. So 360 degrees later, it'll be 0. So negative 270 plus 360 is 90 degrees. Okay, it looks kind of like the graph's doing this. We know what sine looks like. So let's maybe test a few more. How about negative 180? Negative 180, store for A. I'm going to ask my calculator to figure it out. It's telling me it's negative 2. So I'm kind of guessing the graph's going to look like this. But we could keep picking more values if you're not sure. Like if you plug in negative 90, you will see it's 0. If you plug in 180, you will see that it's negative 2. Eventually, you'll get the hang of it. We use the period, amplitude, and phase shift to kind of bring everything together. We'll do one more, and I'll give you some homework. What about if I asked you to graph y is equal to, let's see what I want to do here. How about the secant of 2 theta plus 180 degrees. First thing let's do is let's make sure that theta is by itself. And now we're ready to graph it. There's no amplitude because secant is not a wave. The period, how often this is going to repeat, is going to be the normal period of secant, which is 360, divided by 2. It's going to repeat every 180 degrees. And the phase shift is going to be to the left 90 degrees. So we'll set it up, and I'll show you how to graph something like this. I remember secant looks like parabolas. But our calculator doesn't have a secant button. So what I'm going to do is I'm going to figure out what would the cosine, and by the way, we always graph in our calculator, we always use the original. I'm going to type in what's the cosine of 2a plus 180, and then to figure out what cosecant, or to figure out what secant is, I'm going to do 1 divided by those numbers. Because remember, secant's the reciprocal, so we find cosine, and then we do 1 over that to figure out the secant. So let's start with negative 360. I'm going to hit my calculator. I'm in degree mode. I'm going to type in the cosine of 2 mem variable a plus 180 and enter. I'm going to store negative 360, and my calculator is telling me it's negative 1. 1 over negative 1 is negative 1. That would be what the secant is. Okay. So now I'm going to try negative 270. And by the way, if the period's 180, that means 180 degrees later, it's going to be the same thing. 180 degrees later, it's the same thing. 180 degrees later, same thing, same thing. That's how we use the period and all this stuff to come together. Now I'm going to store negative 270. And I'm getting 1. So 1 divided by 1, because that's cosine, we're going to do 1 divided by that to get secant. It's 1. 180 degrees later, it's 1. 180 degrees later, it's 1. 180 degrees later, it's 1. So we start seeing this pattern, and I remember secant looks like parabolas. So that's what the graph looks like. And we're kind of using our knowledge of what the basic graphs look like to get the real ones. Now, if you weren't sure, you could plug in negative 180, and you'd get negative 1. The reciprocal is still negative 1, so that makes sense. And what about the asymptotes? I mean, it looks like maybe like over here there might be 1. That's between negative 270 and negative 180. So if you plug in negative 225, instead of going up by 90, go up by half of that, you would get the cosine would be 0. The reciprocal of 1 over 0 is undefined, which gives you an asymptote. You don't have to draw the asymptotes. Or you know what, yeah, I would like you to draw the asymptotes, but we're going to be practicing some more try out your homework. Let's see how you do. If you have trouble, I'm going to go over a few of these for tomorrow. So for homework, this is what I would like you to do. On page 315, I would like you to please do numbers 16 to 28 even, and 36, 38, and 40. These are going to be graphs. I want you to graph these from negative 360 to positive 360, just like we did in these two examples. All right, try them out. I don't expect you to get this all today, but we're going to be practicing some more tomorrow, actually Wednesday and Thursday. So this whole week we're going to be graphing. So eventually you'll get the hang of it. But try your best, and I'll see you tomorrow.